company makes and sells fiber optic cables. It can sell at most 200 kilometers of cable in a week. For a certain range, its production companies found that profit can be modeled using the following function. Right, guys? Now, before I start this question, I just want to explain a little thing that you might need for other similar types of question. Hint, hint. Profit equals revenue, which is money you make, minus cost. Okay? Now, imagine there's a cost function, and I set the cost function C of x was x squared plus 2000. And imagine I set the revenue function R of x is 275x. This would mean combined the profit function P of x would be the revenue function Rx, take away the cost, which is Cx. And then you'll need to remember this. It's going to be 275x, take away bracket x squared plus 2000. And then all of a sudden, when you combine both of them together, you get 275x minus x squared minus 2000. Now, it has nothing to do with this question, but just making you aware that sometimes you have to do extra steps where they give you two individual functions in order to get the profit function. Okay? So just be aware of that. I'm obviously showing you this for a reason, so you need to be on the ball with that at a later date. Never know, in a week or two. Now, next thing. We're going to use the profit function to find out how much money the company loses if it does not sell any cable. Well, if you don't sell any cable, it means you're doing P0. And P0 is 275 times 0 minus 0 squared minus 2000. You're basically replacing all the x's with zeros. Now, I'm going to be quite lazy about this. So what I'm going to do is I'm going to do an f of x function, like so. And I'm going to put in the function into my calculator, 275x minus x squared minus 2000. Okay, start at 0. Let's go up as far as 200. Let's go up in tens. And we can see right now what's happening is when you sell nothing, you lose 2,000 euro. When you sell 10, you make a 650 euro. When you sell 100, you make 15,500. And when you sell 200, you make 13,000. So oddly enough, there's a maximum range here. The maximum seems to be 140. If you sell 140 kilometers of cable, you make 16,900 euro. That's the maximum. Okay, so just you can tell that by the calculator straight away. Now, anyways, when you put this into the calculator, you find out your profit is minus 2,000. So you lose 2,000 euro if you sell no cable. In a particular week, the company made a profit of 8,350. Find the number of kilometers cable sold that week. Now, there's a little, we can sort of check the function here. It's somewhere in between 40 and 50. See 40 and 50? That's where you pass out the 8,000 mark. So the answer should be somewhere in between 40, because 40 gets you 7,400 and 50 gets you 9,250. So here's what you can do. You put your profit function, which is your 275x minus your x squared minus your 2000. You put that equal to 8,350. Now we do minus x squared minus plus 275x, and then bring that over to your side, and we get minus 10,350. Just purely because minus 2,000 minus 8,350 is that amount. All right, now we're going to multiply both sides by minus, and now we're going to have to use the minus b formula. Okay, so where a equals 1, b equals minus 275, minus b, however, will equal plus 275, and c will equal 10,350. Please remember the minus b formula. All over 2a. Okay, so minus b is 275 plus or minus the square root of minus 275 squared minus 4 times A times C, which is 1 times 10,350, all over 2 times A. Now, do this in the calculator. We need to get off the table function. Press the fraction button, 275. We'll start off with the plus answer. It can be plus or minus. We'll start off with the plus answer. Something squared minus 4 times something. So we're going to fill out the B value here, which is minus 275. The A value, which is 1. And then 10,350. All over 2 times 1. 230 is one answer. So x equals 230 is one answer. Now, I'm pretty sure they said that x can't be bigger than, we were expecting an answer between 40 and 50, if I remember correctly. So I'm going to try this again. Let's try the minus answer. There you go, 45, lads. That's the answer we wanted. Okay, so we're all good. Okay, so that's pretty handy there. Okay, so we're on to part C now. Use the table function below, shows the data representing the profit on the sales. Use the profit function to complete the table. Okay, so that's not too bad. So what we're going to do is go back to our mode, our table function. We're going to do f of x equals 275x. If I remember correctly, take away x squared, take away 2000. Always double check, lads. Yep, I got that correct. And it wants me to draw it from, wants me to get from 0, 50 to 100. So I suppose I can start off at 0, end at 20 again, no bother. Go up in tens. Now I can start off at 50. Oh, sorry, my fault. Equals 0 to 100. I should end that. Step at 10. So let's start off at 50. 50 is 9,250. And then we'll go for 60. 10,900. 70, which will check our answer, is 12,350, so we know we're right. 80 is 13,600. 90, 14,650. And finally, 100 will be 15,500. Now, I'm sure they'll probably want me to draw this somewhere. Ah, there it is. I want me to draw it here. Okay, so what I might do is I might copy and paste this onto my previous page, and then it's all on the one page, which will make my life fairly handy. Okay, there we go. So let's begin. So 50 is 9,250. So this is 9,500, and halfway between 9,500 and 9,000 is 9,250. So that'll be the first red dot. Next one is 10,900, which will be just below 11,000. So that's 10,900. 70 is 12,350, which will be below 12,500, about just above halfway, because halfway would be 12,250, so just above halfway. 13,600 next. So 13,500 is here, so 13,600 just above it. And 14,650. So halfway above 14,500, about 14,650 around there. And finally 15,500, which is there. Now guys, this should not be a straight line, it should be a curve, okay? So don't use a ruler to draw this. Not talking about anybody specifically. PD. There we go. I do not want to see, when you do this question, I do not want to see this, where you have it all angular like this. I know it looks good for this particular question, but it doesn't usually. You actually use marks for having it like straight lines. You can see there's a discrepancy at the end, so you don't do it that way. Even though for this particular question, it actually seemed to work all right, because it is pretty close to a straight line, but it's not a straight line, okay? Use your graph to estimate the upper range of sales in kilometers of cable in order to make a profit between 10,000 and 14,000 in a particular week. So lower and upper. So here's what we do. We go to 10,000. We draw a line going straight across, and then we draw a line going straight down. I'll say about 55 barrels for that, or 55 kilometers. And then for 14,000, once again, we go straight across for 14,000. We hit the line and we go straight down, say below 85, so about 84. So I'd say about 50, maybe 54 to 80, 54 to 83 maybe, something like that. So 54 and 83. Now you're allowed a experimental error or graphical error. The marking scheme is actually 55 and 83. So look, you can 55 and 83 is the marking scheme answer. But look, if you're on 54, 56 or 84, I'm sure you'd be allowed some small bit of error. Okay, so this is meant to be 55. This here is meant to be 83. All right, let's get going. Okay, next question is, use calculus to find the number of kilometers of cable sold when the profit is increasing at a rate of 105 kilometers, 105 euro per kilometer. Now, profit means when the profit is increasing. When you see the word increasing, it means a positive slope. It means the slope is increasing. So your slope is actually equal to 105. Your first derivative, your function is 275x, take away x squared, take away 2000. Remember, for these things, guys, your first derivative is the slope. So first derivative is 275 minus 2x, and that equals 105. Bring the 275 out of your side, so you get minus 2x equals 105, take away 275, which is minus 170. Multiply both sides by minus 2x equals 170, divide by 2, x equals 85. Okay, so x equals 85. Now, oddly enough, this question didn't actually ask you for the maximum. Remember I said earlier that we knew the maximum. The maximum was 140. Okay, so what I'm going to do here, guys, is I'm just going to practice something for you. Okay, I'm going to make a part E. Find the maximum profit. Okay, because I won't be happy. I think this is a better question. So for maximum, which is your tipping point here, your slope equals 0. I'm obviously doing this for a reason, so you would want to practice this. Then it's 275 minus 2x equals 0. Basically, the slope equals 0. The slope doesn't equal 105 this time. The slope equals 0. The slope is the first derivative. Bring a 2x to your side, so you get 2x equals 275. And 275 divided by 2. So, actually, the maximum probably wasn't 140. It was actually something else. So 275 divided by 2, I'll just do it here. Goes once, 3 times, 137.5 is your maximum. So get this, guys. If we go in here, oh no, 275 alpha x, 275x take away x squared. We're talking about the original function here now, 2000. And we go from, let's say, 135 to 140. Okay. Sorry, even 150. Steps of 1. Look at this. The profit for 135 is 16,900. But you can see the profit is going up. And then in between 137 and 138, the value stays the same, and then it starts to go down again. So it was never 140. So we can see that it's actually halfway between 137 and 138 would be the maximum, which is 137.5. Okay, now we know that we have to find the maximum. So if I did this, if I did start at 137, end at 138, I did a step of 0.5. There we go. We can see the maximum profit is 16,906.25. Okay. So how would you figure this out? Well, you'd find out that your x value when you divide both sides by 2 is 137.5. You already found that out. And then your profit to make the maximum is, remember, it's 275x, take away x squared minus 2000. And what you'd have to put in there is that, oh, and the other thing is you'd sell 137.5 kilometers of your wire. You'd put it into your function like so, throw that all into the calculator, and you should get 16,906.25. Okay, so that's important to know. Okay, there's a bit extra there. Okay, guys, I just did one extra question there. Find the maximum profit. Okay, just to keep us sharp. The probability a person has blue eyes is 0.7 or 70%. A person is chosen from random. What's the probability they do not have blue eyes? Well, it's 1 take away 0.7, which would be the remaining 30%, or 0.3. 2 people are chosen at random. What's the probability they both have blue eyes? Blue eyes and blue eyes. This means multiplication. It means 0.7 multiplied by 0.7, because you have to have both of them, so it's and, which is 0.49 or 49%. Okay, part C. 3 people are chosen at random. What's the probability exactly 2 of them have blue eyes? Well, let's try this. Blue, blue, not blue. Blue, not blue, blue. Not blue, blue, blue. There's 3 different ways this can happen. So, to be blue, followed by another blue, followed by a not blue, is this amount here. To be blue, not blue is second person not blue is 30%, and the third person to be blue is 0.7. And finally, not blue, blue, blue would be 0.3 by 0.7 by another 0.7. Now you can see they're actually the same number each time. It's 0.7 by 0.7. Blue eyes, and not blue eyes is 147 over 1,000, or 0.147. So they're actually all 0.147s. So essentially you're going to multiply this by 3. Multiply by 3, and you get 44.1% or 0.441. Okay, it goes on. We got D next. Probability is handy. 4 people are chosen random, one after the other. What's the probability the 4th person of the chosen is the only one to have blue eyes? Okay, so to get this, you're going to have to do not blue for your second choice, not blue for your third choice, and finally blue on your 4th choice. So it's going to be 0.3 multiplied by 0.3 multiplied by 0.3, and then finally multiply by 0.7. Okay, so it's 0.3 multiplied by 0.3 multiplied by 0.3 multiplied by 0.7, and you get 189 over 10,000, or 0.0189. Okay, and next question. Experiment consists of throwing 2 fair 6-sided dice and recording the sum of the 2 numbers thrown. Some of the totals are shown on the table. Find the probability of getting a 7 or 11. I'm just going to finish off the table. 2 plus 5 is 7. That's a 7. That's a 7. That's an 8. That's a 10. And that's a 12. Remember, you basically add the numbers across. So see this one here, the 12. It comes from a 6 and the other 6. Okay? And let's say the number 10 I did. That comes from a 5 and the other 5. Okay? And then the number 8, the number 7 comes from the 4 mixed with a 3. Okay, so if you don't know what I'm doing with that, okay? Now there's 36 different outcomes, because there's 6 outcomes from the first dice and 6 outcomes from the second dice, which is 36 different outcomes. Now what's the probability of getting a 7 or 11? Well, 7 is 1, 2, 3, 4, 5, 6, and 11 is 2, so 6 plus 2 is 8. 8 out of 36, which will be, what's it, 2 out of 9. Okay, let's keep going. Find the probability of getting total, which is a prime number. Now what are prime numbers? Prime numbers are numbers that have factors of only themselves on 1. not including 1. So here are your prime numbers, okay? So let's see how many we have. 2 can happen twice. Sorry, 3 can happen twice. 2 can happen one way. 5 can happen 4 ways. See 5 there, all the 5s. 7 can happen 6 ways. And finally 11 can happen twice. So it's 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 6 is 13, 13 plus 2 is 15. So 15 out of 36 is what my answer would be. 15 out of 36 is going to be 5 out of 12. Okay, and let's keep moving on here. This is a good question. Hint, hint. Find the number of different arrangements that can be made using all the letters of the word rainbow. Each letter is only used once. So the key is to make 7 different boxes, because there's 7 different letters you can choose from. Okay, so there's box 1, box 2, box 3, box 4, box 5, box 6, and box 7. Okay, now you have 7 letters you can choose to throw into the first one. So that's 7. When you pick a letter at random, there's only 6 letters remaining. You pick another letter at random to go on the second slot. Now there's only 5 remaining. And then you pick another letter at random. Then there's only 4 remaining. Pick another letter at random. And then there's only 3 remaining. Pick another letter at random. Then there's only 2 remaining. And then pick another letter at random. And then there's only 1 remaining. 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. A quick way to do it is the factorial button, where you press 7, shift. Where's the factorial button? It's like an exclamation mark. Should be able to find it somewhere. Ah, there it is. Here. 7 exclamation marks. So that's 5,040 different ways of doing that. Next question is, find the number of 3 letter arrangements that can be made using the letters of the word rainbow. Well, this time we only have this time we only have 3 slots available. Okay, and we're not allowed to repeat the letters. So that's the same as the first question. You're not allowed to say or. You only have 1 or to use. So there's only 7 different letters to use. So you have 7 to choose from at the start. You use up 1 of them. Then you have 6 of them to choose from at the start. Then you use up a second one. Then you'd have a third one to choose. You had 5 to choose from. And now there's 4 unused letters. So it's 7 by 6 by 5, which is 210 different ways of doing it. Okay? Happy days. Now, a game called Rainbow uses an unbiased circular spinner. The spinner has 7 sectors colored red, orange, yellow, green, blue, indigo, violet. This also gives below shows the angle of each sector, and it shows cash prize wins if the spinner stops in that sector. Okay, so here's what we're going to do. We're going to fill out the table first, I reckon. Complete the probability table, no bother, right? So to fill out the probability table, you divide whatever angle you're given gets divided by 360. So your angle divided by 360 tells you what fraction of the circle it represents. So we're going to go for 72 over 360, which is a fifth. 30 over 360, which should be a 12th. Okay, 90 over 360 is a quarter. 60 over 360 is a sixth. 18 over 360 is a 20th, I believe. Yep, and 45 over 360 should be an 8. 1 divided by 8 is an 8. All right, done. Find the expected value. Okay, now do you have to pay to play the game? No, expected value is a way of getting the average result. How much, if this game costs nothing, which it seems they're not charging it for the money here. So what we're going to do with expected value is we're going to multiply each one of these, okay? So you multiply the probability by the amount you're going to win. So it's 20 multiplied by 1/5 plus 60 multiplied by 1/12 plus 24 multiplied by 1/8 plus 8 multiplied by 1/4 plus 42 multiplied by 1/6 plus 90 multiplied by 1/20 and finally 48 multiplied by 1/8. Now I could type all that into the calculator, but that'd take me quite a while, so I'm just going to shorten this down for myself. That's €4. 60 by 12 is €5. 24 by an 8 is €3. 8 by 1/4 is €2. 42 times a 6 is €7. 90 times a 20th I think is €4.5, €4.50. And 48 times an 8 is €6. Then we add all that together. I'm hoping we get €31.50 for this. 4 plus 5 plus 3 plus 2 plus 7 plus 4.50 plus 6. Yeah, €31.50. Okay, we're sorted. Let's move on. Okay. Survey of 168 people was carried out. Participants were asked whether they owned a cat or a dog. Some of them are recorded in the Venn diagram below. On those surveyed, 19 people did not either own a cat or a dog. Complete the diagram. So 19 people owned neither animal, okay, or a dog. So 19 on the outside. Then it's going to be 168. Take away your 64. Take away your 48 and take away your 19, which is 37. And please remember, anything you type in the calculator needs to go down on the paper. Otherwise, you might not get marks if you make a mistake. A person is chosen from random from those surveyed. What's the probability you own both a cat and a dog? People who own cat and a dog are in the middle, 64. So 64 divided by 168. Which is, just keep it as a fraction, I suppose, 8/21. What percentage of people in the survey owned one animal only? Well, that's 37 plus 48. 37 owned a cat only and 48 owned a dog only, which is 85. 85 out of 168 is your fraction, and then multiply your fraction by 100 to change it to a percentage. 85 divided by 168 multiplied by 100, and you get 50.6%, 50.59 or 50.6%. Okay, let's keep driving here. Okay, Mandy wants to buy a ticket for a theatre and she can only choose a ticket in the balcony stalls. Mandy can go on a Monday or Wednesday or Friday, and for an extra charge she can choose a VIP ticket where she'll meet the band and where she can choose the show only. Complete the tree diagram below, hence otherwise find the probability that Mandy chooses a VIP ticket on Wednesday. You may assume choices are equally likely. Okay, so here's what happens. The first thing is whether you're standing or stalls or balcony, okay? So you have a half a probability going to the balcony, a half a probability of going to the stalls. Then you have 3 different dates. You have a 1 in 3 chance of going Monday, a 1 in 3 chance of going Wednesday, and 1 in 3 chance of going Friday. So I'm going to do Monday, Wednesday, Friday also down here as well, and 1/3 each. Next thing, when you're there on Wednesday, you can either go for VIP or show only, and that choice exists for them all. VIP or show only. Okay, so we can do it like this. So we can have a VO, 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 VO. Now, how many different choices are there at the end? Well, there's balcony, Monday, VIP, balcony, Monday only, show only. There's a balcony, Wednesday, VIP, balcony Wednesday show only. There's a balcony Friday VIP, balcony Friday show only. There's stalls Monday VIP, stalls Monday show only, stalls Wednesday VIP, stalls Wednesday show only. Then there's stalls Friday VIP and stalls Friday show only. Now, how many different outcomes were there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different outcomes, and if she chooses a VIP ticket on a Wednesday, how many VIP tickets is there on the Wednesday? Well, there is, this one here is a VIP ticket on a Wednesday. This is I'm trying to highlight this here. This is a VIP ticket on the Wednesday. And this one here is also a VIP ticket on the Wednesday. So I'd say it's 2 out of 12 or 1 out of 6. 2 out of 12, probability is 1 out of 6. Next thing, what we're going to do, garage has 5 black cars, 9 red cars and 10 silver cars for sale. A car selected random. What's the probability that the car is black? All right, 5 out of, what's that, 19, 24. What's the probability the car is black or red? Black cars, red cars. So that's 14 out of 24, which is 7 out of 12. Car selected at random, then a second car is selected at random from those remaining. Find the probability the first car is silver and the second, and means multiply. First car is silver would be 10 out of 24, multiplied by the second car being black, which would be 5 out of 23. So 10 out of 24 multiplied by 5 out of 23, which is 25 out of 276. One of the selected, find out that one of the selected cars is red and the other is black. So that'll be red, black, first one's red, second one's black, or plus black, red, where the first one's black and the second one is red. So that'll be essentially, what's red and black again? 5 black, 9 red. So 9 out of 24 multiplied by 5 out of 23. 9 out of 24 chance of getting the red car first, plus, multiplied by 5 out of 23 to pull the black car second, or means plus, we could do black red, which would be 5 out of 24 to pull a black car in the first place, and multiply by 9 out of 23 to get the red car second. So there's 2 different ways this could happen, so that's why we're adding them together. Or we could just multiply that one answer by 2, but it's going to be 9 out of 24 multiplied by 5 over 23. So what you find is both of them are 15 out of 184. And then add 15 over 184 to itself, plus 15 over 184. And you get 15 out of 92. Okay. So that's 3 of the black cars, 2 of the red cars, and 4 of the silver cars have diesel engines. One car in the garage is selected again at random. What's the probability that it's a red car or a diesel car? Oh God. I think what we'll do here is we will do a Venn diagram to help ourselves. Venn diagram might help yourself picture this, okay? So remember, there's red cars, and then there's diesel cars, okay? And then there's cars that are neither red or diesel on the outside. 3 of the black cars, 2 of the red cars. So 2 cars are red and diesel at the same time. And how many red cars do we have in total? 9 red cars in total. So this means these 7 here are 7 red cars, but they're not diesel. These 2 are red cars and diesel. Now we're looking for the diesel cars. So 3 black and 4 silver. So 3 plus 4 is 7. Okay. One car is selected from again at random. What's the probability that it is a red car or a diesel car? Now let's remember how many cars aren't red or aren't diesel. That's 9, that's 16. So there's 8 cars that aren't red and aren't diesel either. So red or diesel means it can be a red car or a diesel car, or it can be both. So that's 7 plus 2 is 9 plus 7 is 16 out of 24, which is 2/3. Alright, when taking a penalty, Kevin always scores his 3/4. What's the probability he does not score? Well, it's 1 take away 3/4. If he scores 3 and 4 times, he misses 1 and 4 times. Kevin takes 2 penalties. What's the probability he scores both? So score and score. So that's 3/4 and then multiply by another 3/4, which is 9/16. Kevin takes 3 penalties. What is the probability that he scores exactly twice? Okay, so score, score, don't score, no score, score, no score, score, no score, score, score. So that's how many different ways that can happen. That's going to be plus, so it's going to be 3/4 multiplied by 3/4 multiplied by 1/4 plus 3/4 multiplied by 1/4 multiplied by 3/4 plus 1/4 multiplied by 3/4 multiplied by 3/4. So that's how many different ways that can happen. Now, like last time we did something like this, it's going to be 3/4 multiplied by 3/4 is 9/16, and then multiply that by a quarter. That's going to be 9/64. This one's also going to be 9/64, and this one here is also going to be 9/64. Then when you add all 3 of them together, you should get 27/64, which I know is correct. Alright, D. Kevin takes 5 penalties. What's the probability he scores for the first time on his 5th penalty? Well, he scores 3 and 4 times, so that's a very unlikely event to happen. So a no score happens 4 times in a row, and then finally he scores. So it's a quarter, multiplied by a quarter, multiplied by a quarter, multiplied by a quarter, then multiply by 3/4. Now, you could also write that down as 1/4 to the power of 4, multiplied by 3/4, which takes less effort in the calculator. So what we're going to do, I'm going to do 1/4 to the power of 4, or you can do a quarter multiplied by a quarter by a quarter by a quarter by a quarter by a quarter, which I'm even sick of saying it. Okay, so you multiply the 2 of them by each other, and you get 3/1024. Once again, I'll be aware that this is the correct answer, okay? And finally, we're on to the last question in this. Now, we've done a wide range of probability questions. It's another expected value question of a dice game. So for expected value, multiply the number by the probability and add them all together, and you should be able to find it. Basically gives you the average of the game. Now remember, the dice isn't a fair dice because it only has a 10% chance of landing on a 6, but yet a 25% chance of landing on a 1. So it's not an accurate, it's not a fair dice. Okay, so it's 1 multiplied by 0.25 plus 2 multiplied by 0.25 plus 3 multiplied by 0.15 plus 4 multiplied by 0.15 plus 5 multiplied by 0.1 and then plus 6 multiplied by 0.1. Okay, that's 0.25 plus 0.5 plus 0.45 plus 0.6 plus 0.5 plus 0.6. I wonder if I can do this in my head. 1.2, 1.7, 2.2, 2.2 plus 0.7, 2.9. Or you can just try it on here. That's 2.9, lads. Okay, let's move on. The game is at a fun fair. It costs €3 to play the game. The player rolls the dice once and wins back the number of euros shown. The sentence below describes the difference between using above biased dice and a fair unbiased dice when playing the game. If you play the game many times with a fair dice, you win an average of blank per game. But if you play the game with a biased dice, you lose an average of blank per game. Alright, so what they want me to do is they need me to find the expected value of a fair dice. Okay, so expected value of a fair dice is completely different. So remember earlier what happened was now what happened earlier was this, okay? So you have a chance of a 1, a 2, a 3, a 4, a 5, and a 6. Now if this is fair dice, it'll be a 6 chance of rolling the 1, a 6 chance of rolling the 2, a 6 chance of rolling the 3, a 6 chance of rolling the 4, a 6 chance of rolling the 5, and a 6 chance of rolling the 6. Now what we do to find the expected value is we multiply the probability by the value and then we see what happens. All right, so 1 times 1/6 is 1/6, 2 times 1/6 is 2/6, 3 multiplied by 1/6 is 3/6, 4 multiplied by 1/6 is 4/6, and 5 multiplied by 6 is 5/6, and 6 multiplied by 1/6 is 6/6. You're going to add all them together, guys. Or the way you guys might have done it is you might have done it as 1 multiplied by a 6th. Now this is quite arduous to do, but look, I'll do it for you, okay? And then plus 2 multiplied by a 6th. Now this will probably take me the next like 30 seconds, so feel free to fast forward. That's the reason I don't do it like this, unless I really have to. And then plus 4 multiplied by 1/6. If you're not good at the fractions, it's probably best you do it this way. Plus 5 multiplied by 1/6. And plus 6 multiplied by 1/6. Okay, press equals and you get 5 over 2, 2.5. Okay, now here's the deal. When you play with a fair dice, €3, you pay €3 to play, and you win on average €2.50. Is that correct? €2.50. I think I made a mistake using the calculator there, lads. Let's just keep having a look through. There's 3 by a 6th. There's 4 by a 6th. There's 5 multiplied by a 6th. See, I used multiply instead of add. Plus 6 by a 6th. It's actually €3.50, not €2.50, okay? So just got to be aware of that. €3.50, not €2.50. So be careful with the calculator. As I said, if you just add them individually, you might get better. So what happens is, on average with a fair dice, you'd win €3.50, but you'd pay €3 to play the game. So on average, you would win 50 cents a game. Okay, but when you use the unfair dice, which on average you win €2.90, you make a loss of 10 cents per game because you're paying €3 to play, but you only get €2.90 back. Alright guys, I think that's it. That's some pretty substantial revision. My advice for you guys is use the last day on Friday to catch up on your notes and any outstanding assignments, okay?